Okay, so last time we were finding, who remembers what we were finding last time? We were finding the slope of what? Of what? We're finding the slope of a tangent line of what? If there's a tangent line, it's got to be tangent to something. A graph that's given, an equation that's given. We could find the slope of the tangent line at a specified point, or we could just find the slope of a tangent line in general. So we're finding both of those. So now today we're going to put some vocabulary with what we were doing, and we're going to learn what a derivative of a function is. So when we derive a new function, we are finding the derivative. That's why they call it the derivative, because we're deriving a new function. The function can be, not always, but can be denoted by f prime of x. When you see f prime of x, we are talking about the derivative of a function. Okay? The definition of the derivative, f prime of x, is equal to the limit as delta x approaches 0 of f of x plus delta x, subtract f of x, divided all by delta x. That's what we did last class. So you've already found the derivative before. I just wasn't calling it that. I was calling it the slope of the tangent line to a graph. So this will work if the limit exists. This will be differentiable. The process of finding derivatives is called differentiation. Besides f prime of x, you're going to see other notations. You'll see dy over dx. You'll see y prime. You'll see d over dx of some function. And then you might see d subscript x of y. So all of those mean the same thing. So they'll change it up once in a while in here. So example 6, finding a derivative. So we're going to find the derivative, and we're not going to do anything different that we didn't do last class. So we're going to find the derivative of f of x equals 3x squared minus 2x. So we're going to start with f prime of x. So that's the new part. I put f prime of x in front of it. That's what's new. So now we're going to do the limit as delta x approaches 0. And then we have to use the formula, which says to do f of x plus delta x. So I use my x equation, and wherever I see an x, I'm going to replace it with x plus delta x. So we'll have 3 parentheses x plus delta x squared minus 2 parentheses x plus delta x. Then we subtract off f of x. So we subtract off 3x squared minus 2x. And then that goes over delta x. So that's what we were doing last time. And we're going to simplify. I am going to multiply some stuff somewhat quickly here rather than showing every single step because we've already done this. So I'm going to have 3x squared plus 6x delta x plus 3 delta x squared minus 2x minus 2 delta x minus 3x squared plus 2x over delta x. Oops. Looking through there, I'm going to find some terms that will cancel out. That's going to happen every single time. And then after we cancel it out, does anybody remember what we're going to do next? Because I'm going to combine it in the next step. Megan? We're going to factor out that delta x. So I'm going to just kind of do that into the same step here. So delta x is going to come out. I'm going to have 6x plus 3 delta x. And then minus 2 over delta x. So those delta x's will reduce. So we get the limit as delta x approaches 0 of 6x plus 3 delta x minus 2. So wherever I see the delta x, I just plug in 0. It'll be right here. And after we do that, we get f prime of x is equal to 6x minus 2. Bless you. So what does that mean? Let me show you with the graph. Oops. I need my keyboard. So I've got, what's my equation? 3x squared minus 2x. I've got my equation 3x squared minus 2x. Now this equation of, was it 6x minus 2? Is that what it is? Got it. Okay, that will give me the slope of a tangent line at any point on this graph. So let's find a point on this graph. Let's plug in an x, find its y. Let's find a point on this graph. Somebody find a point on this graph. 1, 1. Okay. So if I plug in 1, I get out 1. And there, I just graphed it so you guys can see it. It's there. So according to so this is not what this equation is asking me to do, by the way. We're done with this example, but I'm just kind of going above and beyond because I had a lot of people in first bell that just don't understand what we're doing. Like, why are we doing this? What are we getting? So I'm just going to kind of try to explain that. So 1, 1 is on the original equation. If I plug x equals 1 into this equation, the derivative, 6 times 1 minus 2, that's going to tell me that the slope of the tangent line is 4. Okay, that's going to tell me the slope of the tangent line is 4. Now, if the tangent line should pass through point 1, 1 and has a slope of 4, can we find that line? How can we find that line if we know a point and the slope? Point slope 4. So we'll have y minus y1 equals m times x minus x1. So y minus 1 equals 4 times x minus 1. So I'm getting y equals 4x minus 3. So let me graph that. So when I graph y equals 4x minus 3, do you see how that point goes through 1, 1, and it totally looks like it's tangent right there? I mean, it should be. It is, but you can actually see it. Let's try a different point. What's another point on this graph? What? Yeah, on the original 3x squared minus 2x. 0, 0. Okay. I probably shouldn't need to label it, but I will. It's purple. Okay. We'll do the same thing. I'm going to go back to my work here. I'm going to do just the exact same thing. So my x value in this case is 0. I'm going to plug that into the 6 times 0 minus 2, right? Yes. And I get, no, that's not right. What did I do wrong? Yes, negative 2. I had something wrong in my head. but I didn't do anything wrong. It's just in my head. So I get -2 for my slope. So I'm going to do y minus 0 equals -2, x minus 0. So I get y equals -2x as the equation of the tangent. So let's see. -2x. And there we have a line that is tangent to our original function, right at that point 0, 0. The vertex of this parabola, I can get easily when I touch Desmos, is at 1/3 for x. What would be the slope of the line that is tangent to it at the vertex? Imagine a line that is tangent to that vertex. What will be the slope of that line? Don't really hear what we're saying. 0. So if I have like just y equals 0 in red, you can see, nope, it's not 0. The slope would be 0. My bad. I should have worked it out. So we would have, what's my ordered pair? 1/3, -1/3, I think it was. I think that's what it was, hopefully, because I'm using it. So if we plug in 1/3, we will get our slope of 0. That will happen when you plug in 1/3. And then we would do y minus 1/3 equals 0 times x. Oops, that'd be y plus 1/3, and then this would be x minus 1/3. So that's going to get rid of all of that, and we'll have y equals -1/3. And now you can see that that is tangent to the vertex of the graph. Okay? Do you understand what we're finding? What questions do you have about what we're doing here? So we're going to do another example. Find the derivative of y with respect to t for the function. Use the same formula. We're going to do f prime of x. Actually, maybe I shouldn't do f prime of x. Hold on a second. This one doesn't have any x's. And it doesn't really have an f of anything either. So I'm going to call this y prime. And I'm going to say we're going to do the limit as delta t approaches 0 instead of delta x, because the variable is a t. I always accidentally put x. So if you catch me doing that, just remind me we're using t. Thank you. And then we're going to do f of t plus delta t. So here is where t is in the equation. So I'm going to do 2 over, and I'm going to replace t with t plus delta t minus 2 over t, the function itself, over delta t. Okay, so if I plugged in 0, if I just straight up plugged in 0 right now, we'd have a problem because it's all over delta t. So I need to manipulate this. So if I plug in 0, the denominator doesn't just automatically go to undefined. So let's add together the fractions on top. So to add the fractions, we need a common denominator. I'm just writing up here. I would need to multiply this one by t plus delta t over t plus delta t. And then over here, we'd have to multiply this one by t over t. So I'm just finding my common denominator. On top, that's going to give me 2t minus 2 parentheses t plus delta t over, and then I'll have my common denominator, t times t plus delta t. And then that whole thing over delta t. Over delta t. And then that whole thing 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 over So simplify a little bit. We get two t minus 2t minus 2 delta t over t times t plus delta t, and then all over delta t. Go this way a little bit. I want to write an x so bad. At this point, I'm going to, instead of dividing by delta t, I'm going to multiply by its reciprocal. Instead of dividing by delta t, I'm going to take the top, the two t's cancel out. I get negative 2 delta t over t times t plus delta t multiplied by 1 over delta t. So instead of dividing by delta t, I'm multiplying by its reciprocal. I'm just trying to fix my handwriting here. Okay, when we multiply by delta t, that will cancel out the delta t on top. So the limit as delta t approaches 0, we have negative 2 over t times t plus delta t. That's where I am so far. Oops. If I plug in 0 now, oops, over there. If I plug in 0 now, will the denominator become 0? If I plug in 0 for delta t, right here, I didn't mean for that to be a shape. If I plug in 0 right here, will my denominator be 0 now? No. So I can go ahead and take the limit at this point. So I take the limit, and I get negative 2 over t squared. So y prime equals negative 2 over t squared. So the whole time we're doing the stuff prior to taking the limit is we're just trying to manipulate it so that our denominator doesn't just equal 0 right away. We're manipulating math equations. And that's why you have to go all the way through like algebra 2 to learn all these tricks of manipulation. And then pre-calc is giving you mostly the trig and practicing those manipulation tricks so that you're ready to just dive into calculus and use them. Okay. And then remember, if we have this, I kind of went over this already, but if we have this derivative, and I forget what point they're saying, and they want to know the slope at 0.21, if they want to know the slope for this guy at 0.21, what would I plug in? To find the slope at the ordered pair 2, 1, what would I plug in? Nobody knows? Eden? I would plug in 2 where? Into the y time. Yes, for which variable? Because there's 2 of them. The t. For the t, yes. So this would be like the t, this would be the y. But we are going to plug only in the x coordinate. So we'll have like y prime equals negative 2 over 2 squared. So I'd get negative 1/2. So that would be the slope of that tangent line at that ordered pair, negative 1/2. Okay, the last part of chapter 2.1, this is mostly the stuff that we didn't get to, was just talking about if it's differentiable and its continuity. So in these 4 examples, the function is not differentiable at 0, 0. For all 4 of these functions, it is not differentiable at 0, 0. So it's differentiable at every value except for when x equals 0 for these 4. And the reason why is 4 different things. You can see pictures. If there is a vertical tangent line, a vertical line is not a function, so it's not differentiable at that point. It is differentiable on the points, everything else, but not at x equals 0. Here, when there's a discontinuity on the second one, if there's a discontinuity where the graph breaks, we cannot find the slope of the line right there because it's like broken. Okay, so that is not differentiable at x equals 0. This example here is called a cusp, where it like rounds into a point. It is not differentiable on a cusp, and it is not differentiable on a node, which would be like absolute value, the vertex for the absolute value. So there's 4 examples where it is not differentiable. And then what you can see is the first, the third, and the fourth example, those are all continuous the entire time. They're all continuous. So continuity does not necessarily mean differentiable. All right. But if it is differentiable at a point, then you can say it is continuous at that point. So it goes backwards. So if you know it's differentiable, then you can say it's continuous. If you know it's continuous, you can't necessarily say it's differentiable. That's what that last part is about. So in part of your assignment for this, you're going to be given like a picture. And like for this first example, if you were given that picture, you would say it's differentiable at all values except x equals 0. And then it'll say y, and you'll say because there's a vertical tangent there. So you got these 4 examples to kind of look at, and then there'll be pictures in your assignment. Okay, questions? Okay, I'm going to stop this video.